Hi, everybody. How you doing? Well, good afternoon, everybody. Well, it makes life so much easier to log in and see that there's a cameraman here waiting to take footage. In my C++ class today, I was forced to record my own screen, and it's just one more thing to have to worry about because with the Xbox recorder, whenever I would make a full screen of, let's say, the Google Drive, the Google presentation, it would cut out on the screen recording. So when I used OBS, my computer couldn't handle it. It's just been probably one of the more challenging things. It. I thought I did, but it's the way this Dell works is it's like not a dedicated NVIDIA graphics card. It's like integrated with the Intel chip from what I was reading. And it's it's like if I would put too many things on that, it couldn't get what was on the screen. It's not good. I mean, I would get to see it running, but always a very small percentage. I would never have a lot of the I would never have a lot of it running. And I don't know if it's an issue with Dell, but it just doesn't work well. And I spent a lot of nights working with it. It was just such a pain. Um, in the end, this this Dell had a lot of complaints, this version, about that issue online. And some people said, "Oh, if I upgrade the BIOS, it should help." But in the end, I couldn't get that to work well. So OBS is a lot better than the Xbox screen recorder, just because, like, I don't know if anybody else has used the Xbox screen recorder, but what happens is when I make a presentation full screen, it stops recording. And I just don't know why that happens. I guess I haven't Googled for that problem. So maybe that's something that other people know how to fix with the configuration. But that's with the Xbox screen recording on Windows. But that won't shut my computer down. I can use the Xbox screen recording and it doesn't like cause my computer to uh, go to a halt. But with OBS, no matter how I configured it, it always eventually would catch up to me. I guess I guess I could try again, like making it lower and lower and lower, but like at a certain point we just it's just so much easier, so much nicer. I see there's a cameraman here recording and we're good. Anyways, let's go ahead and get started. So let me do a screen sharing. Okay. So let's everyone jump on to the all right. So now we've got everybody jumping on the screen sharing. Looks good. Okay, great. So let's take a look, see what we have. So if we go to the class syllabus, and then we go down to today's date range, we can see we're going to talk about inheritance and a little bit about coupling and cohesion. Okay. Let's also remind you what's coming up on Memer, or what's on Memer, I should say. So if you go to Memer, you should see the programming test 1, and we see, okay, a lot of people have not started it. So make sure to take time to do programming test 1. So this isn't like the type of assignment you want to skip. You definitely need to do this programming test, and you don't want to wait to the last minute because you might run into troubles. So go ahead and get started working on your programming test 1. Don't delay. It's not something that you want to skip. You don't want to skip programming test 1. So it says the in progress is just because of the deadline. Right. So as soon as you get all the tests passed, you know you're finished. So yeah, there have definitely been people who have finished. They've got perfect scores, but a lot of people still haven't started. So make sure, if you're here right now and you haven't started the test, you got to start the test. You can't delay. It's just too important. So if I can copy and paste the deadline in there. Okay. All right. So let's copy and paste the deadline. So 628, it does give you time. It's not it's not the end of the world, right? If you haven't started it. Most people haven't started it, but you shouldn't wait until the last minute. So, make some time and go ahead and work on that test. And I think you'll find it's a pretty fair test. There's nothing like incredibly complicated. It's straightforward. It's about the things that we've been doing, classes, it's arrays, loops, things like that, if statements. So you'll get multiple attempts. So if you get a 0, a 0, a 0, a 0, if you keep getting zeros on your last attempt, you get them all correct, you get the high score. So sometimes people write me messages that it didn't work and they're on their second attempt or third attempt. And I'm willing to help, of course, but it's much better if you see what the compiler tells you is wrong, see what Memer tells you is wrong, and then try to fix it and then resubmit it. If you can't make any sense of the error, then yeah, sure, I can try to help you. But the only thing that counts is your highest score. So if you even submit the wrong thing and get a 0, it doesn't matter. It doesn't really count against you. It's just, the point is it grades the highest score. That's the way Memer is configured by default. People can go in and punish students, like say, oh, it's the average of all the scores, but I think it's most fair that you get the highest score because people may submit things wrong. Things like that happen. It's not a big deal. Okay, so that's enough talk about that exam. If we go back to and we go look at Java MDC, we check up on code review week 4. And we see it's due on the same day as your exam. So just like in other weeks, you're going to do a code review. And I think people have done a good job on the code reviews. It's not been a bad It's not been bad at all. It's been really good. Okay. So, but there are some people who haven't been doing them, and that's not good. Okay, so let's go ahead and let's get started talking about Java inheritance. So let's click on this link into Discord. So now let's go look at this w3schools.com. So on, oh man, so many different programming languages, so many different front end, back end. It's really a cool site. So here we see Java inheritance. In Java, it is possible to inherit attributes and methods from one class to another. We group the inheritance concept into two categories. So we have the subclass, which is the child, and this is the class. Child would be something like, well, let's look at this ad on the right hand side. So we've got a car. So you might have a class car, and that's the exact example that they give here. How funny. And the class car has certain details. But you know what? Cars share things with other vehicles. So you can have a superclass called vehicle. So class vehicle will have certain things, class car will have certain things, and the whole point is you're logically laying out your nouns in an order from most general, which is the superclass, to most specific, which is the subclass. This is the syntax we need to focus on. Class car extends vehicle. So let's go back here to Discord. And let's put class car extends vehicle. Car is the subclass, and vehicle is the superclass. Okay, so car is the sub, vehicle is the super. You know, we've actually been working with inheritance this whole class. We just haven't noticed it. Whenever we make an object, we could explicitly write extends object. So we could have class student extends object. Now let's go ahead and pull up Java object. The parent class of all the classes in Java by default. Okay, the object class is the parent class of all the classes in Java by default. So if we go to the API, yeah, we can just click on this one up here. And yeah, this will work. All right. This takes us to Java Lang class object. Class object is the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. So I believe last time, didn't somebody ask if arrays were objects during class? Maybe if we search through the Discord chat. Let's see. Yeah, I think it was you. That's right. And now we see if we go to the Java API, the documentation, we can see, yes, even arrays are objects. Primitives are not objects. That's like int. Int is not an object. Yeah, everything is an object except primitives. Yep, that's it. That's what we can say. Everything is an object except stuff that isn't. Yeah. And that stuff, int, double, char, Boolean, those things, short. All right. Good. So let's get back to our inheritance. And we can see that we can make car, my car equals new car. No big surprise. That's what we've done before. But if we scroll down, actually we have to go next. So let's go next. Oh, well, I'm surprised they don't put an example with a constructor. Okay. Example for inheritance. So we'll go ahead and add more examples to that. That was pretty brief on W3 schools. Okay, so let me do a little Control F here. Inheritance. All right, class inheritance. Inheritance slides, and this will help us to understand what it's all about. So I really like these slides. They're from the big Java book, and here we go. So tonight we'll learn about inheritance, see how to inherit and override superclass methods, to be able to invoke superclass constructors, learn about protected and package access control, understand the common superclass object and to override toString and equals. We can use inheritance for customizing user interfaces. All right. So inheritance lets us extend classes by adding methods and fields. So a really common example would be a savings account, which extends a bank account. Savings account usually comes with the ability to generate interest. Nobody's going to be getting this much interest nowadays, but maybe a long time ago you could get that much interest. Today you don't get that much interest. So what's the purpose? The purpose is to divide up your code into its logical components. Also, you don't want to repeat yourself. If there's something that all bank accounts need to do, you make it in bank account. Then savings account will have access to it. Savings account needs to do things differently than other bank accounts. Inheritance lets you deal with that as well. So the extended class is the superclass. Okay, so bank account. The extending class is the subclass or savings. So inheriting from a class is not the same as implementing an interface. It's different. We'll talk a little bit more about that another time. But the big advantage of inheritance is code reuse. We get to reuse classes again and again down the line. So if we were to look at this with a diagram, we'd see all objects like bank account and savings account, they start with class object, right? So bank account extends object. Savings account extends bank account. So what does the syntax look like? Well, we've seen extends before. Public class savings account extends bank account. Now this is the constructor. This is where things get interesting. So we have public savings account that can take in an interest rate. We can have methods that add the interest to your specific account. So here we have interest equals get balance times interest rate divided by 100. Want to try to make your code as hidden as possible. So make your interest rate private. This is encapsulation. So add interest will call get balance rather than updating the balance field of the superclass. The idea is to make data as private as possible. Okay? So we can just skip ahead here. Class subclass name extends superclass name. So in this case, we have savings account extends bank account. Savings account extends bank account. And then we can also add new methods into our subclasses, or we can reuse the methods that were defined if they were public or protected in our parent class. So, which instance fields does an object of class savings account have? Well, balance and interest rate, because that's what we're keeping track of. So, what can you apply to savings account? Well, you can deposit money, withdraw money, you can get balance, you can add interest. All those things are possible with a savings account. So, if manager extends employee, which is the superclass, which is the subclass? Well, manager is the subclass, employee is the superclass. So, you can think about biology. So, we have this Archosaurus. Let's see, we've got a comment here. Let's see. Yes, the manager is going to inherit from the employee. And then from this, we can look at dinosaurs specifically. And then within dinosaurs, we can have, I don't even know how to pronounce that, but birds and fish and all that stuff. Okay, so if you're looking at swing with Java, swing is organized this way. We'll do some swing examples probably. So you have the J component, you have a J panel, J text component, J text field, J text area. Okay, and we can go ahead and skip a few of these, skip a few. Okay, inheriting methods. So to override a method, you supply a different implementation of a method that exists in the superclass. It must have the same signature, the same name, and the same parameter types. So if the method is applied to an object of the subclass type, the overriding method is executed. If you inherit a method, you don't supply a new implementation of a method that exists in the superclass. The superclass method can be applied to the subclass objects. That's because inheritance is this type of relationship. A savings account is a bank account. A manager is an employee. Aggregation is has a. So if you say a car has tires or has an engine, things like that, that's a different logical relationship than a car is tires, right? Because there's more to a car than tires. That's just not the way. So sometimes students will do inheritance in kind of odd ways when they're first learning it. So you'll have class tire and then class car extends tire. And I'll say, well, is a car a tire? And they'll say no. And then it'll start to make sense. But you do sometimes have to step back and think about these relationships. Okay, so you can add methods that don't exist in the superclass, and then it's only applicable to subclass objects. Okay, so you inherit instance fields. You can't override the fields. So all the fields from the superclass are automatically inherited. You can add fields. So if there's a new field that doesn't exist in the superclass, you can add it to the subclass. So what if you define a new field with the same name as a superclass field? Well, now each object has two instance fields of the same name. The fields can hold different values, and this is very undesirable. You don't want to have the same name, pointing to two different things. Not good. So I think right now we should jump into some examples with REPL. So let's all go to Replit. And we're going to do a new REPL. And we'll make it with Java, of course. And we'll call this Inheritance Example 2020. Okay. Let's go ahead here, and you can have a link to the Replit. And today, why don't we just work with very, very, amorphous classes. Like we don't have to deal with anything concrete. We can just deal with things like A and B. So let's have class A, and then class B extends A. So we don't even care what an A is, what a B is. We're just going to have some fields and some methods, and then we'll see how this inheritance works with allowing different fields and methods to be accessible in B and A. Okay? So let's say that A has an int I, and we'll just set it to be equal to 10. And then we'll just have better indentation. So some of the methods, well, we can have public void, we'll have, I don't know, first method. And first method is going to just print out to the screen first method. So really no real point to this. We're just making a method that can be called on an A. Okay? So if we go down to our main method, we can see A, lowercase a, equals new A, and then A dot first method. So if I run this, we're just expecting to see first method on the screen. Nothing surprising. Now let's go ahead and make a B. B equals new B. And if I say B dot first method, what's going to appear on the screen? Well, same thing, first method. So this is our first example of inheritance. We can now use the method inside of B, even though we didn't define it there. So that's what we're talking about, code reuse. We are saving copy paste time. Okay. Now, let's say that we want to change first method inside of B. This is called overriding. Okay, we want to override this. So we're going to go back here. And inside of class B, we're going to say public void first method. And then we're going to say system.out.println B first method. Now, if we run it, got to put my semicolons. Forgot my semicolon. We can see that now we've changed first method. We've overridden first method. Okay? So oftentimes people will put a tag like this, @override. And the reason is because they want to make it clear that they're overriding a method that was, that's weird, it didn't, that's strange. I don't know why the code isn't showing up. Let me delete this comment. Well, this is known as an annotation. So let's look up Java annotations. Okay, so let's take a look at annotations. Annotations are a form of metadata. They provide data about a program that is not part of the program itself. So, yeah, I would say that this is kind of similar to a comment, sure. Annotations have no direct effect on the operation of the code they annotate. Annotations have a number of uses, among them, information for the compiler, compile time and deployment time processing. So in a way, it's not like a comment, right? Because if it's used by the compiler, that's how it's different. A comment is just totally skipped over by the compiler. So that's a difference. So in a way, they're similar, but in a way, they're different. Comments are just ignored by the compiler. Perfect. Good. So I do have to say one thing that I really like about class over Discord is the questions are just so good. In person, I don't know. It's maybe this is just like a really good class, just really involved. But yeah, that's just a little more info about annotations. Okay, great. So let's go back to our example here. Oh, another question. And you're awesome. And that is kind of true. Speaking in public can be awkward for some people. So, I mean, for me too, for everybody. But yeah, I like the way. In a way, I like this a lot. It's nice. It's nice to get to see students in person, but it's also, I don't know. It's been not too bad. All right, good. So now let's go ahead and let's make a constructor. So let's say public A, and yeah, I would say it's interactive. And I think Discord plays a big role in that. I think I'm really happy with this. So what we can do is we can go ahead and add a constructor, and the constructor is going to take in the A. Okay, so we're taking the I, excuse me. We're saying an A has to have an I. The A has to have the I. So you can't make an A without the I. So let's go back here and just type it in so we can all look at it. So in this case, because we've changed the constructor, we've now said that to be an A, you have to supply an integer. We call it I, but there has to be an integer. So if we were to rerun this code, we'll see an error. It says constructor A in class A cannot be applied to given types. All right, this is the actual error. And this is because we told the compiler that you have to send it an integer to make the A. And we said that a B is an A. A B is an A. But think about it. We didn't send it an integer to B. So the compiler says, you can't do this. This is against the rules. So if we go here to B, we can now change it so it will work. We can say public B takes in int I, or we can call it int x if we wanted. And now here's some new syntax. Super send up the x. Okay. Super is how we access the parent constructor. So now if we run it, still doesn't work. Why not? Let's see. Oh, it doesn't work because down here, I have to send in the numbers into the main. So I have to add in, let's say, 4 and 3 or 4. Doesn't matter. 7. Okay, now we run it. Hopefully it all works. Okay, perfect. So this is the point. We can change our code as long as we follow the rules of the parent class. So if we say, all right, every A has to have an integer, if we say that B's are also A's, then we also have to have an integer. So you can think of this like a contract, a way of ensuring that certain things are met. Okay, well, why don't we do an example that's less abstract and something more like relatable? So somebody throw out an idea, something that we can use inheritance with. So we've already seen car in the slides, so no car and no bank account. We'll just put some things what not to do. But it could be just about anything other than that. Okay, actually, yeah, a human parent and child. That's perfect. I don't think anyone's done that before, but I like it. That's good. So let's go here and let's do a new REPL. Let's call it parent child. Well, you're talking about like a a human parent and child, right? Yeah, like genetics. Like we'll talk about we can talk about different traits and different things like that. Yeah, so like genetic, yeah, perfect, perfect. So we can go here and we can have class human parent, and then we can have class human child extends human parent. Okay. And now we can say there's certain things about, gosh, genetics. This is going to get really, really interesting. So we could talk about blood types. I don't know who's taken biology class recently. What sort of traits can we deal with here? Eye color. Yeah, okay, eye color. That's perfect. I like that. Yes. That's good. Eye color, hair color. Yeah, and you know what we can do? We can look up eye color genetics chart. Oh wow. This is really interesting. Oh wow. This could take us all day to program. This we have to do simple examples. Yeah, this can be I mean I figured genetics would be complex, but I don't know, we just have to simplify it. We're obviously not going to do like a full example. We're just going to pick a few traits. Um So let's see. Yeah, we'll pick the most likely. So we'll do exactly. We just have to get something off the ground, right? Just something to show this example. So it looks like if they both have brown eyes, the chance is 75%. We'll just do the first one. Okay. So here, for the human parent, we have a string eye color. Okay, let's see. Okay, so people were just posting in my other class Discord. Throws me off. Okay, so we have string eye color. We can do. Let's do height. Int height in inches, and um, one more. Yeah, that's good. We'll keep things as simple as possible. Okay. Now we're going to make our constructor, so we can say public um, human parent, and then we have string eye color, and then int height inches. And thinking about the eye color, because we only want it to be certain things, it might make sense to make that an enum. Um, and yeah, but right now a string is fine. Like, we just have to make a simple example that we can work with. Then we can say this dot eye color equals eye color. And then this dot height in inches, height inches equals height inches. Okay. Now, here's the thing. With our human child, right now, the way we have it set up is we have it set up, the human child gets certain traits that have to be there. So we have to deal with eye color and height in inches. So we can have here public human child. Yes, the constructor is inside the class. Yeah. The constructor has to be inside the class. Now here's an interesting question. When we say the human child is a human parent, that now the logic is getting thrown off a little bit. Like, now that I'm in the middle of doing this and I'm saying a human child is a human parent, this is kind of, you see what I'm saying? This logic sort of breaks down to me, right? Like, just let's think about this. Human child extends human parent. A human child is a human parent, right? They're both people. So I just think we should maybe change the names of them. That's what's throwing me off. Like, I don't know if that's a great name. Well, they might be. I mean, most will, but many won't. This is the sort of like design decision that there's not always. The child is an extension of the parent for sure. So we could have. I'm just thinking about the naming of it, like calling it human child, human parent. Does it work? Let's see. Human child extends human parent. Yeah, I mean, I guess it makes sense to write human child like that. I don't have a problem writing this. I'm getting flustered because I have to turn off notifications for my other class. They're just nonstop beeping. All right, so human child extends human parent. So now we have to say public human child, and then we have string eye color, and then int height, and then we can just say super eye and height. Okay, so here's the main point. The main point is this. We now have, oh, how do I mute that? I just right click on it. Wow, that's awesome. Thank you. Wow, that's so good. Oh, that's so nice. Because I don't know, I mean, you probably heard the beeping, but it was just beep, 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 like C++ students nonstop. So yes, perfect. Yes, yes, yes. That's really nice. And I can't believe I didn't know that. I could have just saved myself so much hassle. That's great. All right, cool. Super. So let's see here. So we now have a human parent and a human child. We can just post the code here. And we can see that the human child is going to be the subclass. Human child is the subclass. And the human parent is the superclass. All right. So some of the syntax that we're seeing for the first time. We've got extends. We've got super. And we've got an annotation that's new. At override. All right, so 3 new things we've seen. And, you know, the way we stopped and we thought about the connection, that's important when you're doing inheritance. You don't want to just try to use inheritance for everything, but inheritance is a useful tool. And I think now is a good time for me to show you the Mario code. I've been showing it for years and years. So I see somebody typing a question out, but then I'll show you the Mario code. Okay, super refers to the parent class. So super accesses the parent or superclass. So in this case, we're just talking about the super class constructor. Could I send a link to this REPL? Sure. All right. So, other questions about what we just typed out? Okay. So, I think I've got a really cool example that I've been showing for years and years, and I think it still works. So, let me go ahead and just search for it on the page here. Um, where's the Mario code? Am I in the right one? Let's see. Java MDC. All right, let's see. Maybe I'll just go directly to GitHub and find it. GitHub Mario Java. Mario Java. Okay, Super Mario. Ooh, oh, this is kind of cool. Yes, this is it. This is it. Yes, yes, yes. This is it. All right. So let me go ahead and just answer this question, then I'll point it out there. So we see, okay, so basically, when we have human child and human parent, we're saying that a child is going to have the same things as a parent in terms of they both have eye color, they both have height. So we have to have the same info for the child as we do for the parent. And that was that example with A and B. If we have an A that takes in an integer, and then the B doesn't take in an integer, Java won't let it compile. So if we say that the child extends the parent, and then the child doesn't have an eye color or a height, it's just not going to work. It won't compile. And the way that we go from one constructor to the other is with the super call. So we'll have super, and then you send in the string, and then you send in the int. Okay, and that super we're talking about from the child class. Does that help? Good. Perfect. Yeah, they're the same. They just are a string. And I did do them differently just to point out that you can have different variable names in different classes if you want. Like maybe it would be better to be consistent and just have eye color in both, but it will compile and work as long as you have that order. You have the string and then the int. So the example I hope will run in REPL. We're going to find out. We're going to try to run it in REPL. Yes, because it extends. Because it extends. So you're saying that the relationship has to be the same. All right, so this is going to be a bit of an experiment. Let me go ahead and copy this link to the GitHub. and then I'm going to paste it here for you. Okay, so a lot of you are interested in video game programming, and even though we are going to not spend too much time on this, I think you're going to like it. So you can see it's kind of bilingual. It's definitely bilingual because he has, instructions written out in English, and then he has a link here. He calls it Programming Heroes. Just writes about how he makes this game. Okay. All right. So let's go back here to REPL, and we'll make a new REPL, and we'll call it Mario Game. And we're going to actually, no, I don't want to do that. We're going to just import from GitHub. Okay, you see how you can pick create new REPL or import from GitHub? Scratch what I just said. We want to import from this user's GitHub. Okay, so if you copy Programming Heroes Super Mario Java into Replit, it takes you to Programming Heroes Super Mario Java. Then we say import from GitHub. So you guys should try this too. Follow along. I'm hoping it compiles and runs. We're going to see. I don't know. Because this is a fairly new feature, the import from GitHub to Replit. Okay. So it says select language. So this is a Java project. So we can just change it to Java. And configure the run button. Well, let's see. Probably for the run button, it's going to be just running this main.java. So let's see. How am I going to get to that? That might be a little pain. Might be easier just to use the command line. So I'm just going to say done. Okay. And then I'm just going to maneuver the command line a little bit just to try to get to this main.java. And then hopefully we can get it to run. So let's see. ls. So cd into source, and then cd into com, cd into blogspot, cd into Programming Heroes, cd into Super Mario Java. And let's see, if we want to Java C everything, will a star work? I forget. Let's try it. And oh boy, we got a lot of errors. That's not good. And we're getting them for unmappable characters. Darn it. So this looks like Replit is not making this as easy as when I do it with NetBeans. So if anybody can get this to run on Replit, I think that would be really, really awesome. I mean, it doesn't help that it's not fully in English, but okay, this was an experiment. I thought I'd try running it, but without running it, I just want to show you some of the code. So you'll just have to trust me that this code will run, maybe not on Replit, but it definitely runs on NetBeans, and it's super easy to run on NetBeans. You just download it and run it. Maybe I'll show it another time, but for now, I just want to show you how he designed his classes, because that's really the most important thing anyways, right? Like, you don't want to sit there and watch me play a Mario game. So you just have to trust me. I've tried this code out before. He made a clone of Mario, and it's pretty impressive. Like, he put a lot of work into this. So let's go here, and let's start with class sprite. So we can all click on class sprite. All right. So if you're following along, just go ahead and click on class sprite. Now, if you're inside of GitHub, let me show you how to get to that. Okay. If you just want to view this inside GitHub, here, I'll give you a link to GitHub. Okay. So just click on that link to get to sprite.java. All right. So just the link above. And this is a serious thing. If you can get this running on Replit, we'll say extra credit. But because when I tried compiling everything, I got a whole bunch of errors. And, so if you have some extra time and you like a challenge, just see if you can do it. And maybe I'm just missing a simple thing. I don't know. But let's go ahead and look at sprite.java. So I'll look at it inside of my REPL. And we see here, we have public class sprite. And then we have public static Boolean draw bounds. That's going to be false. Then we have protected float X and Y. Now, protected is an important term. Protected is an important term. So a lot of times I like showing how Java code works, not just by looking at slides, but by looking at real code from a real game that actually works. So protected means that you can access this float in any child class. This can be accessible by all the children of Sprite. So anything that's in that hierarchy, any class in the hierarchy. All right, so let's continue on. Let's keep reading through this. Okay, then we're going to have the width and the height of the sprite. We're going to have the Z. Now we're going to have an array list of bounds. Okay, so we have to see where can this sprite go. What's the speed of the sprite? What are the image names that you associate with this sprite? That's going to be in an array of strings. All right, then we have an image. We have an image index. We have a stage. We have if it's visible. We have if it's active. That's a true false. We have if it has a preferred size. We have if it is deleted or not. Okay, so now we get to the next bit of code. So we're on line 101. So we've talked about this before, but what is this code called that I now have pasted into Discord? What's just the terminology for that code? Yeah, it's a constructor. Exactly. So the constructor can set certain fields. Okay. So we're saying, all right, this sprite has a stage. We're going to send in. We're going to set the X, Y, and Z all to nothing. We're going to set visible to be true, active to be true, preferred size to be false, delete to be false, image index to be 0. The speed is equal to new vector 2D. That's going to be another class in his project. The bounds equals new array list of rectangles. So game programming is a lot. Like this man spent a lot of time developing this Mario clone. We're just on one class sprite. So let's go ahead now and let's look at what this sprite is used with. Okay, so let's go to class Mario. And wait. Should we go to Mario next? Yeah, let's go to Mario. Okay. So now we go to Mario. So let's all click on class Mario. So click on that link. And then we see, all right, public class Mario extends player. So Mario is not a sprite. That's not the relationship. We're saying that Mario is going to come from player, right? So we can go ahead and just post this in here. So before we can understand Mario, let's just take a brief look at player. So let's click on player. And hopefully this is making things easier. Just you can click on the link. And we can see with player that player is an abstract class. Okay? Player is an abstract class. Now, this is something we have never seen in our class before. We have never seen abstract class. But an abstract class really isn't that complicated of an idea. An abstract class is just a class that you can't turn into an object. So abstract classes cannot become objects. So it's just an idea. Like we have this idea, what is a player? This programmer said, all right, we're going to have a player, but you can never make a player object. You can just keep track of certain things with the player. Why? Because this programmer thought it would be more logical this way. Connection is really bad. Are other people having that problem? Okay. Okay, that's good. So what I can say is if that happens, just try logging out of Discord and then coming back in. That's usually the best advice for this. So abstract means you're never going to have a player object. It's just can't be done, right? So what is kept track of inside of a player? Well, he's going to set certain fields. And these are public static final int fields, meaning they can't be changed and they're going to be the same for all the different items that are considered players. So let's go ahead and paste this into Discord. All right, so we can see not jumping. All right, well, Mario sometimes doesn't jump. Rising, sometimes Mario is on the way up. And then falling, sometimes Mario is on the way down. These are the different states. This is how it's being kept track of inside of this program. Now, at first, when it didn't run on Replit, I said, oh, it's not a big deal. But there is something kind of fun about seeing it run and then watching it happen. But you'll just have to use your imagination. Everybody has seen Mario before. So it's not that big a deal. So what else is inside of class player? Well, we have a lot of other states. So we have the image, the left stop, the image right stop, the image left jump, right jump. We have a lot of different strings that we're keeping track of. Okay. And continuing down the hierarchy, we can also see world object. So let's all click on world object before we go back up to Mario. So if we go here to world object, this is the world object. And let's see how he did the hierarchy here. So he said, now we're getting to sprite. Good. Okay. So public class world object extends sprite. Okay, so now we've traced it back. Perfect. So now we have our hierarchy pretty clear. So the way that he designed it was he designed sprite Well, first of all, everything comes from objects. So you have object to sprite to world object to player to Mario. Okay, so this is how the problem looked to him, to this programmer. He said, okay, we've got objects in Java. Then we're going to have sprites. We looked over how sprites have certain images. Then we have a world object where we keep track of certain things. Then we have a player. Then we get to Mario. Now, for each of these classes, we can see sometimes over 100 lines, right? So world object is about 65. Then if we go to sprite, sprite was pretty long. Sprite was really long. Sprite was almost 600 lines, 585 lines. Really, really long. All right. So super, super long. Let's go back to Mario. So let's all click on Mario. Okay. So we've kind of gone up and down the hierarchy, seeing one, going to another, going to another. And now we'll just take a look at Mario. So here we are with Mario. So Mario extends player. So if we look at what I just wrote in our hierarchy, that makes sense, right? So public Mario gets a stage. And what do we see here? We've got a call to super. So the stage is going to be sent up the hierarchy. Then we're going to have set preferred size. We've got the bounds. Okay. We want to know how big is Mario because we have to deal with collisions. Nice. Logging, turning off and on. That always works. So now we have the size of Mario, the bounds. We've got the create keys. So this isn't about inheritance, but it's still interesting. What do you guys think this is for here? Yeah, exactly. To move around. How do you get Mario to move around? So if you want him to jump, you press space. If you want him to run right, you do key right. Okay? So let's see. Then we have the creating the images. Let's see if the images load up in here. Maybe that is the problem. So if we go here to res, and then we go to images, and then we go to Mario, and then we go to says some files may fail to load in the browser, but sure looks like Mario. Oh, that's a pretty cool one. It's pretty cool. Anyways, you can play with this a little more and look at how to get it running. But the point is to just take you on a really brief overview of how inheritance might look in a real project, right? And it's a huge code base. I mean, nobody is just going to skim over that and say, "Oh, how simple! He made a Mario clone." This is a big undertaking. There's thousands of lines of code. Hopefully, we can just get the main ideas about how the different classes relate. And there might be other programmers who look at his. I think this wasn't given the needed stuff to run on Replit. That might be. Maybe there are just missing things when he uploaded it. Um, Actually, I used to see this on SourceForge. Let me see if I can find it. It just takes a second. Yeah, you have to add some buttons. Okay, let me see. Let me let me see if it's still on SourceForge. So if I go here, Programming Heroes. Okay. mm, Let me see. Super Mario SourceForge. This might be it. This might be it. Mm, No, this is not it. This is interesting too. Let's add Java. Um, One. For some reason, the link that I had before on my site, Java MDC, I just don't see it. Mario. Oh, yeah. Let me look at one more thing before I give up. So let's go here to summer. No, that's not it. Okay, well, not a big deal. We'll just move on. So if you wanted, they have other Mario clones. I mean, we can just go to GitHub. GitHub's like the number one place to go to look for code. We can just type Java Mario, see what we get. So we have this one's built with libgdx. That's kind of cool. This is a project for school we can look at pretty quickly. And he made it in Java. He used, oh, he's got AI. Well, I guess you'd need to maneuver things. Um, yeah, his AI is pretty simple, right? Like it's kind of funny. Sometimes you see AI.java, and yeah, if I ran it in Eclipse, it probably would run. Um, I don't know why I'm so committed on just running it in Replit because I have run it in other IDEs before and it worked. So, but I'll just draw your attention to this. He has abstract public class AI, and so you think AI, and it's like going to be super long, but he's just basically setting the direction and getting the walk speed. It's nothing terribly crazy difficult. All right. Well, okay. So right now, I only wanted to use Replit. Now, for your final projects, you're gonna probably pick the IDEs that you want. The only reason I'm like slow to start up a new IDE is because when people start installing IDEs at home, whether it's IntelliJ, it could be NetBeans. Like I've used all these different IDEs, right? I like them; they're really good. The only thing is I get so many messages. This won't install, this won't install, this won't install. And this isn't like a diss on any students. It's just sometimes people just have trouble getting IDEs installed on their computer. So if you could get IntelliJ or NetBeans installed, I would say install IntelliJ. I mean, do it. Like everybody who's listening right now, you care about this class, you want to get good at programming, you want to be a good Java programmer. It's good to have a working IDE that's like outside of Replit because it does have more features than Replit. I really like that Replit is just you just run with it, you know. The only thing about the direction is different configurations have different issues. Like let's say somebody has a Mac, right? And they have trouble getting it installed. It's just going to involve a lot of okay, this is the error. We do a screen share, and you know it's just time consuming. So I would say like at this point in the class, I don't think we need it. If you could just get an IDE installed on your own without having trouble with me, um, like without bothering me at this point, then that would be good. And I only say that because I'm getting so many messages like every day. You heard the C++ students message, message, message. People are really just having issues with the syntax right now. Like they're trying to wrap their head around how to write the code. So yeah, IntelliJ is probably the most popular now. IntelliJ is free if you're a student. It's not really that hard to install if everything goes according to plan, right? Like for most people, it's going to be okay. For some people, they're going to have trouble. Like right now, since I'm just talking, yeah, I'd like you to click on the link, try to install it. Some of you might have trouble getting it installed. Like that's always happened when I've taught this course. People have always, yeah, some people have tried it and they really like it. And did you have any trouble installing it? See, okay, a lot of people won't have trouble installing it. I'm just nervous about the people who do have trouble installing it because sometimes it's just their computers are really old and it's like a hardware issue. It's like they're running it on super ancient technology and um, it's kind of a pain. So yeah, eventually I think for your final project it would be good if you had an IDE. But look, Replit is getting really powerful and a lot of people won't need to. So that's why I didn't really make it like a big deal in the course. I mean, that seemed to be an issue that we couldn't run the Mario game in Replit, but I mean, there we go. So that's just a little talk about IDEs, and let's see if some other people have some questions. Windows 98 computer. Yeah, that would be pretty funny if someone had a Windows 98 computer. Java is from the 90s. Yeah. I Java is at this point pretty old technology. And the code base is huge. It's going to be around for a long time. So, well, yeah, if their computer was that old, then they wouldn't be on this Discord chat. That's true. Yeah, and they definitely have, yes, they have made Java better. There have been a lot of changes. They keep adding new features and it's pretty interesting. So even though it's an old language in some ways, well, it's not as old as C, but they definitely keep adding features. And there's tons of libraries for Java, so it really is a good skill to learn. So if you get a chance, go ahead and install IntelliJ. If you do have troubles, you can send me a message. I can try to help you with it. Hopefully it won't be anything too crazy difficult. I have had issues with students in the past where it was like they try again and again and again. Eventually we'll get it, but most people will have no trouble. It won't be an issue to install it. Okay, so let's go ahead and let's close down this Super Mario Java, and let's actually go back to these slides. Okay, so we'll get back to a much simpler example. Public class checking account extends bank account. So what does a checking account need to do? Checking account needs to deposit withdraw, deduct fees, and it may need a transaction account. Okay? Is there something special that causes issues or just random stuff? Like what issues do you mean? Oh, you mean in installing the IDE? I would say for installing the IDE, what issues can come up? People just don't have enough RAM. Yeah, linking to the proper directory where Java is installed. That's another one. Um, so sometimes it's hardware, sometimes it's just the steps that they do when going through it. But it would be a minority of students who come to me with issues. Yeah, I mean, it if it was like everybody had trouble installing it, nobody would do it. But it's most of you would be fine. Most of you are going to be okay. And then those of you who can't get the IDE installed, then you can just send me a message. Okay, so let's see. Um, each checking account is going to have two instance fields. It's going to have a balance inherited from bank account, and it's going to have a transaction account, which is new to checking account. So now we can apply four methods to checking account objects. We have get balance, inherited from bank account, deposit, where we send in an amount, which overrides the bank account method, withdraw, which overrides the bank account method, and then deduct fees, which is going to be new to your checking account. All right, so let's look at the deposit method of checking account. We can now add transaction count inside of our deposit. All right. But we can't just add the amount to the balance because the balance is a private field of the superclass. Here's the important lesson. A subclass has no access to private fields of its superclass. The subclass has to use the public interface. So, can't just call deposit in the amount. In the deposit method of checking account, that's the same as this.deposit. Instead, this is the key thing. We've seen this syntax before. We call super.deposit. And now we're going to call the deposit method of the bank account class. So when you see super, just think of the super class. That's it. That's all it means. Okay. So now we have our method. We've got public void deposit. We send in an amount. We increment our transactions, our transaction count, and then we're going to call the superclass and just deposit this amount. Okay. So what's the overall syntax? Well, we just have super and then dot method name. If you have super and then parentheses, it'll just call the constructor of the superclass. All right, so here we see our checking account extends bank account. See, you got it working in IntelliJ. Wow, awesome. Could you do a screen share and show everybody the Mario game working? I'm going to end my streaming, and if you're willing to do a screen share, then you can do a quick screen share just to show the Mario game running. So, I mean, you guys are also like some of the top commenters. So I know you're like, very attentive to things. So, and I'm just saying, like, some people have issues getting IntelliJ installed. Most of you won't. Most is good. If you do have trouble, it's not a bad thing. It's not a big deal. All right, let me stop my screen share, and we've got the cameraman who's now going live. So let me stop mine. Let's all join the cameraman. It's hard to see the animation. Yeah, that's it. All right, we can jump off the stream now. All right, great. So let's go back here to general. Yeah, it's waiting for you to extend it. Yeah, totally. Like that's the cool thing about open source code. Open source code means you can totally run with it. And the reality is there are tons of games out there, right? Like I've just shown that one through the years because I really like how there's class Mario, there's class player, there's down the line, and it really just shows inheritance in action. So even though like he did that game 10 years ago, that's probably when I first started showing it. The code is good. The comments aren't even written in English, but his code is it's descriptive enough to still follow it. And I think in a way it's inspirational because it's a big undertaking, but it's just something cool to look at that probably you can start making a little more sense out of. All right, so now we can continue on a little bit. And let's see, where should I continue to? Okay, here we go. So, subclass construction. Super, followed by a parenthesis, indicates a call to the superclass constructor. So, public class checking account extends bank account. Public checking account, inside of here, we are going to make a call to the bank account constructor. To do that, we use super parentheses and then send in the data that's needed. Okay? So if the subclass constructor doesn't call the superclass constructor, the default superclass constructor is used. That's come up in this class. We've talked about if we don't make a constructor for a class, Java provides the default constructor. So the default constructor is a constructor with no parameters. If all the constructors of the superclass require parameters, the compiler reports an error. We've seen that with different examples we've been doing with Replit. Okay, so overall, what's the syntax? We've got the class name, any parameters. We send the superclass the parameters. So here we see public checking account, double initial balance. We have to send initial balance up. All right, so I think that's good for the slides. Let's go back to Replit and let's do a new example. And this time you guys are going to do a little bit of coding. So let's make Java and we'll do an animal example. Animal example. Okay, so inside here, we're going to have our animal example. Let me just copy this REPL here. And we're going to say that we have class animal, and we're going to even make this an abstract class animal, because what's an animal? An animal, that doesn't really exist, right? But we're going to have specific types of animals that will extend it. So for our abstract animal, we're going to say that we have a string name or species, and we're going to have a double weight in pounds. And we'll just add one more thing here. We'll say, I don't know, it could be anything. It could be string sound. Okay, what's the main sound we associate with this animal? And it could be multiple sounds. We could have an array list of sounds. So we could just have import java.util.arraylist. we'll have array list of strings, and this will be sounds. Okay, so now when we make our constructor, yeah, abstract classes can have methods for sure. Abstract classes can have methods. Okay, so let's go ahead and make our constructor. So we can say class animal. Well, no, not class animal. Public animal, because we want this to be accessible. Then we've got string species, double weight in pounds, array list of sounds, and then we can just say this dot species equals species. You know, Java does have a certain amount of boilerplate. Then we can say this dot sounds equals sounds, and kind of went out of order. So I have species weight and weight. Okay, so now that's good. So this is our constructor, and we're saying for all animals, we have to deal with this. And even if some animals don't have a sound, we'll at least just send in the string no sound or silent. Okay, so let's go ahead now and make a method that all animals have to do. What's a method that all animals have to do? What do you think? Eat. Very good. Perfect. Let's do eat. So we can say public void eat, and we'll just say whatever, to be implemented by other classes. All right. So now we have a constructor, we have an abstract class animal. Now, if we tried to make an animal, let's see what would happen. We can say animal A equals new animal, and the animal's going to have species of canine. It's going to have a weight in pounds of 30 pounds, and we'll just send in null for the sounds, just to see if this works. So we run it, and we see, won't work. Animal is abstract, cannot be instantiated. Okay, so look here. If you make animal abstract, you can't make an animal object. But instead, what we're going to do is we're going to use child classes to deal with eating and all the other info about animals. Okay? So why don't we go ahead and make a class dog? Class dog extends animal. And then we're going to say, okay, we've got public dog, and the dog has a particular species. And then the dog has a weight in pounds, and the dog has certain sounds. Okay, now here we have super constructor animal is undefined, must explicitly invoke another constructor. So Replit is warning us. We have to say super species weight in pounds and species weight in pounds and sounds. Okay, now we're getting somewhere. But let's look at eating. Well, let's say when a dog eats, it's going to display something to the screen that says, dogs are omnivores, but mostly carnivores. I don't know if that's true. I just I think it might be true. Okay. So, can we have multiple constructors within our class dog? Yes, we can. We can have public dog, okay? And then inside of our dog, we're going to send up to our superclass like this, dog species. Let's just hard code it. So a dog, what's the specific species of a dog? It's called this. So we're going to say this is the species. The particular weight in pounds will read in. So we can say double weight. And we can put just double W. Okay. And then how about the sounds? Well, the sound of a particular dog is probably not going to be that different. So for a generic dog, we can just make an array list of strings. Just call this one sounds equals new array list. And we can just add the sounds are bow wow. Sounds are rough rough. Okay, you get the idea. We're just sending up these sounds. Now, we look here. Constructor call. Oops, yeah, that needs to be first thing. That was a mistake. All right. So let's go ahead here and put this up here. And great. We'll just call this generic dog sounds. Then we'll just send up generic dog sounds. Okay, so what's the purpose of all this? Why are we doing all this? What's the purpose? Well, we go... Okay, now I'm getting an error. Cannot reference an instance field while explicitly invoking constructor. I did not know that. All right, wasn't expecting that error. So let's see here. Maybe if I make a new new just generic array list. Let's see. New array list of strings, and we'll just send in rough, rough, and bow wow. All right, let's see if this works. All right, somebody do some Googling. How do we make a generic array list Java? So I'm running into a little syntax problem. So let's say anonymous array list. Let's say that. Anonymous array list. Anonymous array list. And here it is. This is the syntax. Okay. All right. So we have here this. Yes, yes, yes. Perfect. Okay. We say it's got open curly brackets, add rough, rough, add bow wow. That's it. Okay, let's see if this works. But it's giving me an error right here. It doesn't like this. Two. I see. Okay. So we do 1, 2. Okay, that was some syntax I do not remember. Oh, okay. But it still doesn't like it. Well, problem. Get extra credit. So the problem is this. I'm trying to make an array list on one line, right? But I'm running into some syntax errors. And this anonymous one doesn't seem to be working. So if somebody can help me figure this out so I can just make it on one line, it'd be really, really cool. But if not, we can just tweak this example and it won't be a big deal. All right, let's see. So we go here, we got to make a dog. Dog D equals new dog. And I think for dog, we had to send in the weight. And let's try to run this. Oh, wait, now it looks like it likes it. Okay, it's fine. It did like this. All right, so this syntax works. So Replit was making me nervous because Replit wasn't accepting it, but it worked. So it's fine. So that definitely did work. Okay, so let's go over what we're doing here and get back to the main point. So the main point is this. We have an abstract class animal. And the animal we can't make an object out of. We can't have any animal objects. And I will get to an example that you guys are doing in a minute. For now, I just was doing a lot of typing. So the animal, we're saying all animals have to have a species, they have to have a weight in pounds, and they have to have an array list of strings that represent the sounds that they can make. Okay? Now we can look at our class dog. So our class dog will extend animal. We have two ways of making our dogs. Okay? So I want you to focus on the constructors inside of class dog. The first constructor for dog, we are just going to read in from another point in the code the species, which is a string. We're going to read in the weight in pounds, which is a double. And then we're going to read in an array list that was made somewhere else. And the array list has to have sounds that are going to be strings. And then we're going to take these three variables and just send them up to the parent constructor. So we're going to send up the species, weight in pounds, and sounds. And then I just wanted to make another dog, another constructor for the dog. We haven't made any dog objects yet. And this time I just wanted to take in the weight. Okay? So I just have double W inside of the parentheses. So the second dog constructor only takes in the weight of the dog. But that doesn't mean the animal constructor has been changed. The animal constructor still needs the species name and it still needs the sounds. So I had to just look up with Google, what's the name of the species for a dog? It's Canis familiaris. All right. And then I was running into, then I sent in the weight that we had above, and then I was running into some syntax troubles. The syntax troubles were, I couldn't have an array list above that I was sending to the parent constructor. All right. At least that was what Replit was telling me. And then as I was typing in the syntax, Replit was saying it was underlining it. I was getting worried. I was saying, oh, is this not going to work? What's the problem? Then I ran it and it worked. So the red underline was throwing me off. Replit had a red underline, but it still worked. Okay. So I got this from a tutorial. I just needed to do a array list. Okay. So then we are going to make eat. So eat is going to say dogs are omnivores, but mostly carnivores. Dogs like to eat meat. All right. Now we're going to get to our first example of creating the object. So we have dog D equals new dog. I just sent in 45.4. So I'm going to be calling the bottom constructor. Either constructor will work to make a dog object, but both constructors have to deal with the animal superclass, right? And that's the whole point of today's lesson. The whole point of today's lesson is all about inheritance. It's all about going from something like animal to dog. Okay, so I thought there was a question coming, but I guess not. So why don't we do this? Why don't we do this? You will now write a class cat, add two instructors, and add the eat method. So I want you to take this code that I just gave you, right? This code that I just gave you, but fork it. If you start typing in that code, it will fork it. So we'll say replet will fork the code. Okay? And this is how we're going to do our participation tonight. You're going to do a class cat, add two constructors, add the eat method, and then you're done. Add a class cat, add two constructors, and then add the eat method. And then exactly into the animal example. So you don't have to recreate the animal. We're not even touching dog. Dog is just there as an example for what to do. But you will have to deal with the sounds of a cat. So cats do meow, things like that. So post a link to your REPL when finished, and I will take attendance. The constructor is this. This is a constructor. No, the just eat. Eat's the only method. Just eat and the constructor. This is a constructor. Well, you just say what a cat eats. So you can say cats like cat food, something like that. But no, you're making a whole new class. So this is the constructor for dog, but you change it for cats. Now we're saying that cat is an animal. So that's the whole point of this inheritance example. So you will have to deal with the species, the weight in pounds, and the sounds for the cat. Those three need to be there. So a call to super is necessary. No, there's no output for this. This is just to see if you can get the syntax. There's no need to loop through and make the sounds or anything like that. So just see in the next 13 minutes if you can make the constructor for the cat and make the eating for the cat. So you could do it exactly like I did with the dog, except just change it from dog to cat. Um, it's just all about what you read in to the second constructor, right? Like you can just ask for the weight of the cat. You could you could ask for the weight and the sounds, right? Like it's just about switching it up. So one could be if you want to know what to do, you could just do one has the weight and the other has all three. You don't have to prompt the user. You could just type it in like I did with the dog. No scanner needed for this. Um We don't need JBoss or Java EE or Timeleaf. We don't need Spring, Groovy. Basically, you don't need any of those additional libraries, but you do need an SDK. Yeah, you do make two constructors for the cat. So one cat, you can read in just the weight, and then you send it up to the animal, and then the other, you can read in all three. Okay. Well, there's basically nothing to run. It's just if you can get your class cat done. Like there's no real output for this. Yeah, this is perfect. This one's perfect. Right. So this one, excellent. And yeah, as soon as you get the thumbs up, you're free to have a good night. But don't just immediately look at someone else's code. See if you can get it running on your own. All right, two constructors for this one. That's good. What would the cat constructors be in it though? Is it the cat sounds and what they eat? Well, the constructors are everything that just say cat. So if you've got cat that reads in the weight, and then cat that reads in the weight and name or species, those are the two constructors. But both cat constructors do need to call super. Both need to call super. Okay, so we have public cat. Yep, that's a good constructor there. Yep, question. Um, the ad, the ad really it it shouldn't need to be in both. Um, all right, let's see. Let me. The question: why do you have both ad inside and outside the super? Really shouldn't need to be both. You're talking about adding the sounds, right? Then there's the question, is there anything I should know when I instantiate an object using superclass? Well, okay, so yeah, this is a good question. Superclass n equals new subclass. You can do that. You can have object O equals new string. Um, that's something legal in Java because it just gives you more flexibility. Probably it's better to be more specific a lot of times, like, subclass n equals new subclass. But there are often times when you'd want to have superclass n equals new subclass. So you can always go from the general reference to the more specific object. All right. So let's see. I meant, why do you add to the array list inside the super command and outside of it? Yeah. Once you get the thumbs up, you're excused. And if you have a working example that you post up there, it's probably going to take me a little while to get to it because I have a lot of questions. So if you're in a hurry, you got to go somewhere, you can log off. That's fine. Um, but inside the super command and outside of the super command, it should be. I mean, it's like if you're making the anonymous. If you're making, let's go back to look at this. Let's change this one here. Okay. So now we have a dog with the dog here, and then let's go ahead and make a method called play sounds for the dog. Okay, so we're going to have here public void make sounds. And then inside of here, we're just going to loop through for each string sound inside of sounds. Then we're going to just display system.out.println sound. Okay, so then we'll have here system.out.println dogs. So let's go here and call for this dog play sounds. So we say d dot play. I think I called it make sounds. Okay. Yeah, make sounds. So we call d dot make sounds. So d dot make sounds. So let's run it. So now we should get some output. And we see dogs, ruff ruff, and bow wow. Okay. So now this works. And we only needed to put the sounds inside of the super, right? So let's go ahead and just copy this here, then paste it back here. So see, the sounds can be inside. Perfect, good. All right, so let me go ahead and check some of these. And let's see. Second constructor is just to take different attributes about that specific animal. Like one cat, you can read in the weight because a specific cat has its own weight. And then another cat might make different sounds. So you might have like a generic cat that has meow and hiss, right? So most cats have just send in the weight. Then you might have a cat that, in addition to a weight, you also want to have specific sounds because this cat, I don't know, hums or something weird, right? So the point of the second constructor would be to take in unique sounds, which would be strings, an array list of strings for that cat, as well as the weight. So it's just to have two different ways to send in the attributes. Now, the species, all cats are pretty much going to have the same species. So, I mean, I guess for house cats, but then again, you think about tigers, they have different species. But you get the idea, right? Like different constructors take in different information. Perfect. Good. Okay. So let's see. We have an array list of sounds. Yeah. So everybody was adding the sounds inside and then outside. Somehow that got a little lost in translation. Oh, that was in my frantic moment of thinking Replit was telling me something was wrong. So I was responsible for that. Okay. All right. All right. This looks good. All right. This cat, destroyer of worlds. I like that. Here, this deserves to be pasted. Destroyer of worlds. All right. That makes sense. It was copied from mine. That's why everybody has it. Hmm. So this has the feline public and okay. Okay. Oh, I see. Yeah, this is a good I like this. This is good. So look at how simple these constructors are. I like these two simple constructors. So I said make two constructors for the cat, and then look what the student did. They've got feline, tomcat, two, meow. Look at that. Two different. This is a generic constructor. This is the one where you at least taken the weight. The only thing I would say is for this one, if you read in double W, you should probably use that instead of just hard coding the five. Okay. Okay. So we've got my actual cat typed into the code. Nice. And let's see. So let's see. Jasenia, you have the frowny face, the confused face on this one. Are you still here? Yours is good. That fulfills two constructors. Oh, I had those for fun. Okay, gotcha. Nice. All right. All right, guys. Well, as soon as you finish, you're free to have a nice day, and we're definitely over time. Wait, no, 5:20 to 7:30. We're not over time. We're doing good. It's not bad. I was thinking we were overtime, but we're not even at time yet. Dog, cat. Ah, okay. So this one needs a second constructor. Wait, this one.